Welcome to Learn with us. This is the fourth practical of Basic Electronics.
What are the objectives of this practical? The first objective is to introduce the basic structure of an oscilloscope. The second objective is to get familiar with the operation of a function generator instrument. And the third objective of this practical is to visualize and measure the amplitude and the frequency of different types of waveforms that are produced by function generator. What is an oscilloscope? An oscilloscope is a laboratory instrument which is commonly used to display and analyze the waveform of electronic signals. The device consists mainly of a vacuum tube which contains a cathode, anode, grid, X and Y plates, and a fluorescent screen. When the cathode is heated by applying a small potential difference across its terminals, it emits electrons. Due to potential difference between the cathode and the anode, these emitted electrons accelerate towards the anode, forming an electron beam which falls on the screen. When the fast electron beam strikes the fluorescent screen, a bright visible spot is produced. The grid, which is situated between the electrodes, it controls the amount of electrons passing through it, thereby controlling the intensity of the electron beam. The X and Y plates are responsible for deflecting the electron beam horizontally and vertically. A sweep generator is connected to the X plate, which moves the bright spot horizontally across the screen. The voltage to be measured or studied is applied to the Y plate. The combined sweep and Y voltages produce a graph showing the variation of voltage with time. Now, how you are going to calibrate an oscilloscope? You perform this quick functional check in order to verify whether your instrument is operating correctly or not. First, turn on the instrument. Wait until the display shows that all self-tests are passed. Then, connect the probe to channel 1 on the oscilloscope. To do this, align the slot in probe connector with the key on the channel 1 BNC. Then attach the probe tip and reference leads to the probe connectors. Then push the auto set button. Within a few seconds, you should see a square wave in the display. This auto set button automatically adjusts the vertical and horizontal scaling as well as the trigger coupling type and position, slope, level, and mode settings. In general, you will use an oscilloscope to measure characteristics of a signal such as magnitude, period of oscillation, the mean voltage, the peak to peak voltage, and the root mean square value of one cycle of the waveform. For measuring these characteristics, you press the measure button on the front panel. You can also change the position of waveform horizontally and vertically using X and Y position controls. You can also change the scale of waveform using scaling control. Now, what is a function generator? A function generator is an electronic test equipment which is used to generate different types of waveforms over a wide range of frequencies. Function generators are capable of producing a variety of repetitive waveforms such as sine wave. A function generator will normally have the capability to produce a standard sine wave output. This is the standard waveform that oscillates between two levels with a standard sinusoidal shape. Next is square wave. A square wave is normally relatively easy for a function generator to produce. It consists of a signal moving directly between high and low levels. Next is triangular wave. This form of signal produced by the function generator linearly moves between high and low points. Next is pulse. A pulse waveform is another type that can be produced by a function generator. It is effectively the same as a square wave but with the mark space ratio very different. Next is sawtooth wave. Again, this is a triangular waveform but with the rise edge of the waveform faster or slower than the fall, making a form of shape similar to a sawtooth. These waveforms can be either repetitive or single shot. Function generators are used in the development, test, and repair of electronic equipments. Now we will understand function generator controls. First is frequency control. It is used for selection of frequency range. Second is function control. It is used for selection of particular waveform. A total number of 6 different waveforms can be selected. First is sine wave, second is square wave, third is triangular wave, fourth is ramp, fifth is pulse, and sixth is sawtooth wave. Third is modulation control. It is used for selection of frequency modulation. Next is amplitude control. It is used for selecting desired amplitude of the waveform. Now, what is your lab activity? First, turn on the oscilloscope, then connect the function generator to one vertical channel of the oscilloscope using BNC connector, then select the type of waveform by pressing function control button on function generator, then set the waveform at desired frequency by adjusting frequency variable control button on function generator. Then adjust the amplitude control of the function generator to establish a desired peak-to-peak waveform on the screen of oscilloscope. Now, what are your post-lab tasks? First question is, what are the applications of different types of waveforms? And second question is, what are the different types of function generators? You have to answer both of these questions.
Thank you for watching this video. If you have any questions, then write your questions in comment section of this video. Don't forget to subscribe our channel and share it with your friends and family. Thank you.